Hello guys and welcome to another lesson of Mossy Maths with me, Tom Moss, and today we're going through the third lesson on surds. In this lesson we'll be reviewing the key points from lessons 1 and 2. We'll also be going through 3 exam style questions, one of which is taken from an AQA textbook and the other 2 from external sources. But both of these also refer to the AQA course. So, in the previous video we looked at how we can rationalise a denominator with Kim, and we looked at 2 key examples that we got from an AQA textbook. Well, in this we'll be looking at a little bit of rationalising the denominator with this first question, and in these we'll be looking at how we can simplify down surds. So let's get started with this question, and it says express 5 root 8 plus 6 divided by root 2 in the form n root 2, where n is an integer. Now if you're not sure, an integer just means a whole number. So let's consider the 5 root 8. We can split the root 8 up into its factors. Well, 4 multiplied by 2 gives us 8. And the square root of 4 is just 2, so we can simplify this. This is 5 multiplied by 2 root 2, okay? Where the root 4 is just 2. So 5 multiplied by 2 multiplied by root 2. And this just gives us 10 multiplied by root 2, 10 root 2. Now we focus on the second term in the question. So with this we have a surd on the denominator of the fraction, and in the previous video we looked at how we can rationalise the denominator. And all we do is we multiply this whole thing by a separate fraction with both root 2 on the numerator and denominator. So we do 6 root 2 divided by root 2, multiplied by root 2 divided by root 2. Now 6 times root 2 is just 6 root 2. And root 2 multiplied by root 2 is root 4. Now hopefully we can see that the square root of 4 is just 2. So we're going to get 6 root 2 divided by 2. And this simplifies. 6 divided by 2 is 3 root 2. And we're adding these in the question. So we can expect now to just add these 2 things together, because remember, the 5 root 8 is the same thing as 10 root 2. These are both equal to each other. We've just simplified them. And the 6 divided by root 2 is also just 3 root 2. So it's fine to add the 10 root 2 and the 3 root 2 together, because it's the same thing as just adding these together. But we're going to get 10 plus 3 is 13 root 2. Okay, 10 root 2's and 3 root 2's gives us 13 root 2's. And there's the answer to the first question. Now with the second one, if you like, you can pause the video and have a go at home, and I'll go straight through it with you afterwards. So, okay guys, hopefully you paused the video and had a go. The question says, show that the square root of 50 plus the square root of 18 divided by the square root of 8 is an integer, and find the value of the integer. So it might be a temptation here to rationalise the denominator because we have a surd of root 8. However, in this question we are just looking at simplifying these, because all of these 3 terms will break down into its factors. So let's consider the square root of 50 initially. Well, we can split that up into the square root of 25 multiplied by the square root of 2. 25 and 2 give us 50. Now the square root of 25 is just 5 multiplied by root 2 is 5 root 2. So root 50 is the same thing as 5 root 2. Now let's consider the square root of 18. Well, we can split this up into the square root of 9 times the square root of 2. 9 and 2 do make 18. And the square root of 9 will simplify to just 3. Okay, 3 squared is 9. Multiplied by root 2. And we can see we're going in the right direction, because we have the square root of 2 in both of these simplified forms. So we can easily add these together, which will be important later on in the question. But we do now need to consider the square root of 8 on the denominator. Again, this will break down into the square root of 4 times the square root of 2. The square root of 4 is just 2. So this is 2 multiplied by root 2. So let's rewrite this question with the simplified versions of each of these terms. Now the root 50 is the same thing as 5 root 2. The square root of 18 is the same thing as 3 root 2. And the square root of 8 is the same thing as 2 root 2. Well, 5 root 2's add 3 root 2's is 8 root 2's divided by 2 root 2. Now this question says we're going to get an integer, just an integer. So we're not going to get a surd, and here we have 2. Well, firstly, the 8 divided by 2 gives us 4. So what about the root 2 on the numerator and the denominator? Well, actually they just cancel, okay? Because the square root of 2 divided by the square root of 2 is just 1. Any number divided by itself will just be 1. So they really cancel out. Anything multiplied by 1 is itself. So we can just cancel them out, so we just get 4. We just get 8 divided by 2. Right, so now for the AQA textbook example. And this says, express the square root of 63 minus the square root of 28 in the form k root x, where k and x are integers. So let's consider the square root of 63. Well, we can split this up into, well, the square root of 7 times the square root of 10 would be the square root of 70. So the square root of 7 multiplied by the square root of 9 is the same thing as this. 7 times 9 is 63. The square root of 9 is just 3, so we're doing 3 root 7. 3 multiplied by root 7. Now consider the square root of 28. Well, 7 and 4 make 28, so we can split this up into the square root of 7 multiplied by the square root of 4. The square root of 4 is just 2, so this is 2 multiplied by root 7. Now remember, the question is subtracting the square root of 28 from the square root of 63. Now, the square root of 63 is the same thing as 3 root 7, and the square root of 28 is the same thing as 2 root 7. So we're doing 3 root 7 minus 2 root 7, which is 1 root 7. And it says k and x are both integers. 1 is an integer, and the square root of 7 is an integer. The 7 is an integer, okay? The root x, it says x is an integer. So 7 is an integer. So this is correct. However, we may need to now just write this as a square root of 7, because 1 multiplied by anything is itself. So we can neaten this up. 1 root 7 is just the same thing as root 7. However, don't forget to write it in this way before, because the question does say k root 7. So we're showing that 1 is equal to the k and 7 is equal to the x. But then finish off by simplifying into this form. Okay guys, so that's the lesson reviewing the topic of surds. In my opinion, you'd be looking at getting maybe above 5 marks in an exam just on the surds topic. And if you can do all 3 of these questions, I see no reason why you can't score full marks on this topic. And it's not the most difficult topic in Core 1 either. So it's very important that you do understand what we're doing here. And this pretty much is all surds is. So if you followed this quite easily, then hopefully you'll be able to move on to my next video where we look at a different topic. So thanks a lot guys. If you found the video helpful, then please put a like, please subscribe to my channel. If you do have any questions, do put a comment below. So thanks a lot guys, and I'll see you in the next lesson.